He talks about the Copenhagen interpretation of quantum mechanics, which is, basically what we've been looking at here, that there is no... so Einstein said the reason why these things act strangely and weird is because there's some other physical things that really do exist that are perhaps interfering with them or something like that. The Copenhagen interpretation says, no, there isn't. There isn't. That's just the way it is. They're just weird. Right.
So when it comes to the math, there's a question of, is it the fact that you can do the math? It's relatively straightforward, so it works. Hey, look, it works. Great. But as John Gribben calls it, quantum cookery, which is always fun when scientists have a good little turn of phrase there. What isn't clear, however, is how the mathematics should be interpreted. That is, what the math says about the observable realm, and why is quantum theory is so often interpreted instrumentally. Well, because the math works. But is that math reflecting of what actually happens? Maybe. Sure. So it's true that there's only one mathematical formalism for quantum theory. So physicists have no problem with going ahead and using the theory, even though they do not agree what it means. Which seems like an odd thing for scientists to do. Oh, it works. We
have no idea why, what it means, or that sort of thing. One problem, he says, is that according to quantum mechanics, subatomic particles, like electrons, do not have a definite position and momentum prior to our measuring them. Right. And so a single particle isn't really a particle as we understand the term, but instead can act like a wave. So particles are smeared, he says, ghostly entities unlike anything we can visualize or even imagine. So it's crazy, and yet the theory works, and it's been confirmed. So instrumentalist view about the two most confirmed theories that we have. That is, we don't have to say that the entities that are posited or even the theory itself is true. All we need is a theory that works, that allows us to make predictions, that is successful in that way. And that's all we need, says the instrumentalist.
So just as with...
in fact, it may not be true.
Well, and Newtonian mechanics allowed us to predict where Uranus would be. And so here we're coming up with... we have theories that are giving us true and useful results. So... Newtonian mechanics was perfect. Well, except now we know it's been replaced by these two. By relativity and quantum mechanics. So just because, again, the point is that just because something works doesn't actually mean that it's true. That it represents true notions of what's occurring in the universe. It just might be helpful to advance the theory or to find Uranus if we ever need to do that again.
So it says another way of putting all of this is that quantum theory isn't an explanation of the physical world. It doesn't tell us what's really going on at the subatomic level behind the observable scenes, So it's not really an explanation. It doesn't tell us what's going on, It just allows us to make good predictions and to work with the theory, He quotes John Bell here. Quantum theory does not really explain things. In fact, the founding fathers of quantum mechanics rather prided themselves on giving up the idea of explanation. They were very proud that they dealt only with phenomena. They refused to look behind the phenomena, regarding that as the price one had to pay for coming to terms with nature. It is a fact of history that the people who took the agnostic attitude towards the real world on the micro-physical level were very successful. So not only does it not tell us, not explain, they were proud of the fact that it didn't explain.
Which is how we saw the logical positivists viewed science. So we're even... Harkening back to Hume's, fork, and going back to the what happened to academia when the logical positivists came into view.
In fact, Stokes tells us, listen for Hume's ghost and fine statement about this foundational period. The quantum theory, and here's the quote by Arthur Fine. The quantum theory that developed in 1925 to 1927 was quickly interpreted as providing no more than a device for coordinating the outcomes of all conceivable experimental procedures, right? He says, Stokes tells us, and as we saw, this human-inspired instrumentalism is popular even among today's physicists. Yeah. Right? So, quantum theory, the most successful theories that we have, the most confirmed theories that we have, began with the founders being instrumentalists and continues, at least the most popular interpretation of it is an instrumentalist interpretation of the quantum theory, right?